Okay, class. Next, we are going to learn tangent to a circle. Okay, tangent to a circle. What does it mean by tangent to a circle? So, of course, you know what is circle. Circle is a round shape, and it is a 2D shape. And then when we talk about tangent to a circle, it actually refers to a straight line. You see the blue straight line here. Okay, what can you say about this blue straight line? Apart from it is a straight line, okay, what can you notice here is that this straight line is touching the circle, okay, at only one point here. Okay, so the definition for tangent to a circle is a straight line which touches the circle at a point. Okay, so this blue line is actually tangent to a circle, or we can call it tangent line or tangent. Okay, so the touching point here, we call it as point of tangency, or maybe we could call it as point of contact. Okay, contact between the tangent and also the circle. So this is the definition for tangent to a circle. Okay, next. Do you know the difference of the three lines below? Okay? Yeah. So, this one you learn at the very beginning, which is chord, and then this one you just learn. Okay? A minute before, you just learn this one, tangent. And another line, we call it second. This is not in your syllabus, but I put it as extra note, okay, for your extra knowledge. So, second is actually a straight line that touches the circle at 2 points, okay, or passing through the circle at 2 points, okay. Okay, so this is the definition. Chord is a straight line that joins any 2 points on the circumference without passes through the center of the circle. Okay. Meanwhile, second is a straight line that passes through any 2 points on the circumference. Tangent is a straight line that touches the circumference or the circle at only a point. What is the name of the point again? Point of tangency. Okay, next. State the name of each line in the diagram below. Okay, so as you can see here, there are 4 lines here. Okay, so what is the name for each of these straight lines? Okay, what is the name for line DF? It starts with C. We call it chord. Okay, how about straight line BC? It is a straight line that touches any 2 points on the circumference and passing through the center. So we call this as diameter. Okay, make sure you know how to spell. And this one you just learned before. Okay, it is a straight line that passes through the center, passes through the circle at 2 points. So we call this as secant, S-E-C-A-N-T. And as for line HTK, we call it tangent because it is a straight line that touches the circle at only 1 point. Okay, next. Tangent to a circle. Okay. Okay, this is what we learned before. Okay, now I want you to notice, whenever you have a circle and then it happens that there is a straight line touches the circle at only a point, okay, when this happens and then there is a straight line drawn from the center to the points of tangency here, this line we call it radius, right? Okay, you know this is radius. So what is the reaction happen when radius meet with the tangent? Okay, it actually form up 90 degree here. Okay, so the radius that passes through the points of tangency, this one, passes through, or maybe chun on that line, okay, just perfectly on that line. So it's actually perpendicular to the tangent and form an angle of 90 degree. So this is what you need to remember regarding the concept of tangent to a circle, because this will help you to do calculation later. Okay, when you have this 90 degree, you can do a lot of things, especially Pythagoras theorem and also trigonometric ratio, because all these we have to use right angled triangle, right? So right angled triangle, normally we have 90 degree. Okay, so you just simply join these. Okay, so you can get a right angle triangle to help you to do the calculation. Okay, for example, okay, so what is the value of x? How could we solve it? How could we solve it? Okay, since angle OAP is 90 degree, you know why? Because this is radius and this is the tangent, this is the contact point. So the reaction between these two will form up 90 degree. Okay, so this is a right angled triangle. You have this 90 degree, you have this 65. So in order to get x, okay, you need to use 180 minus 90 and minus 65. So the answer is 25 degree. Okay, next example. Okay, how can we solve this? Find the value of x and of y. Okay, let's look at x first. How can we find x? Okay, this actually 140 degrees is actually the angle subtended at the center, right? Subtended at the center by arc AB. And this angle, the purple color one, is actually angle subtended at the circumference, also subtended by the common arc AB. So this angle, the angle at the center, is actually two times the angle of the circumference. So actually angle ACB, okay, is equal to 140 divided by 2. So we get 70 degree. Okay. Next, we are going to find this angle, the measure angle of AOB. Okay. So we know that angle of one whole turn is 360. So in order to get measure angle AOB, we use 360 minus 140. So it's equal to 220 degree. Okay? So sum of angles of a quadrilateral. Now I want you to focus on this quadrilateral. So we got here 40, here 70, here 220. So in order to get this angle, angle OAC is actually equal to 360 minus the other three angles. Okay, so the answer is 30 degree. And as for this one, we know already, radius and also a chord, we will form up 90 degree, right? So in order to get your x, you need to use 90 degree minus the angle OAC just now. Okay, so 90 minus 30, you get 60. Okay, and then in order to get y, we need to look at this isosceles triangle. How do we know this is isosceles? Because two of the legs are equal. So in order to get this angle, okay, angle OAB, we need to use 180 minus 140 and then divide by 2 because these two angles are equal. Okay, so we get 20 degree. And now you can find y, right? Because this angle, the radius and also the tangent, they will form up 90 degree. So 90 degree minus 20 degree that you got before. So the answer for y will be 90 minus 20, 70 degree. Okay? Okay, next we are going to learn properties of two tangents to a circle from a given point outside the circle. This one is a very important properties. Okay, so listen carefully. I will explain it slowly. Okay, so this is a piece of paper and I draw a circle. Okay, of course circle we need to have center, right, before we draw it. So this is the center. I denote it as O. And there is a point outside the circle, which is P. And from point P, I draw a tangent to a circle. Okay? Remember what is tangent? It is a straight line that will touches the circle at only a point. So this is the contact point. Okay? So we call this line as tangent. Okay? And then I draw a radius from the center to the contact point, or to the point of tangency here. So what do I get here? I will get 90 degree. Okay, so angle OAP is actually 90 degree. Okay, let's say I draw another tangent, again from point P, but this time I'm going to draw it upward, and then it also touches the circle at only a point here. So this is actually another tangent, right? Okay, and then I do the same. I draw the radius, okay, from the center to the points of tangency here. So I denote this one as B. So angle OBP will be 90 degree. Okay, so this is from what you have learned, just that I combine it. Okay, now, okay, this one I already explained just now. Okay, for the next one, OA is equals to OB. Why? Because OA and OB are actually the radius of the circle. So of course they are equal, right? Okay, next. Line AP and line BP are actually equal. Okay, if this is the case, then you can make conclusion. Line AP and line BP are equal. That's why I use the two small line here to denote their equality. Okay, next, if I draw a line from the center to the point outside the circle, okay, the green color straight line, okay, so actually I will be having two right angled triangle, one below here and one up here, right? Okay, so what do I get? Okay, look at this angle. Angle OPA is actually equals to angle BPO or OPB also. Okay, so these two angles are actually equal. That's why I write X. Okay, so this is what I explained just now. Angle OPA is actually equal to angle OPB, which is X. Okay, next. How about this angle? Angle AOP. Okay, Y is actually equals to angle BOP here. This one also Y. Okay, so these two angles also equal if this is the case. Okay, so this is what I explained just now. Okay, now what about I sum up 2x and 2y here? Okay, so I will get 180. So it means that this angle and this angle are actually opposite to each other. So their sum will be 180. Okay, and then if I draw a chord from point A to point B, okay, so what will happen? What conclusion can I get? Okay, so let's say the chord and the green colored line, straight line, that intersect at Q. I denote it as Q, so that is easier for me to explain to you what will happen next. Okay, so if I draw a chord here, okay, then AQ, line AQ, the length of line AQ will be equal to the length of line QB. Okay, so AQ is equal to BQ, or QB is the same actually. Okay, so that's all for these properties. Okay. Okay, let's look at some example regarding the properties that we talked just now. Okay, we've discussed just now. Okay, now let's look at this diagram. Okay, so you see, you see a circle, and then two tangent here. Okay, and the question wants you to find x and y. Okay, so what do you know about this angle and this angle according to what you learned just now? They are opposite to each other, right? So in order to get x, you need to use 180 minus 30. So the answer will be, sorry, the answer will be 150, yeah? Okay, I forgot one here. Okay, 150. Okay. And then to find y, okay, you need to look at this triangle, the one which I colored the line with red color. Okay, so actually angle, this triangle is actually an isosceles triangle. Okay, this is actually an isosceles triangle. Okay, yeah, an isosceles triangle are having two legs of the same length, right? So this length and this length are actually equal. So it means that this angle and this angle are also equal. If this is y, this one also y. So in order to get one y, you need to use the sum of the interior angle of triangles, okay, which is 180 minus 30 and then divided by 2 because you only want one y. Okay, so the answer will be 75 degrees. Okay, next example. Example 13. Okay, find the value of x. How do you get x? Okay, what property can I use? Am I going to look at the angle? Since there's no angle given, x squared plus 8 is actually the length of AB, and then 33 is actually the length of AC. So what can you say about AC and AB? Okay, let's look at the solution. Okay, so this is actually radius and then tangent, radius, tangent. So according to properties of two tangents to a circle from a given point outside the circle, we can conclude that AB is equal to AC. So you make one equation from this property. Okay, so x squared plus 8 is equal to 33. Okay, and then you move the 8 to the right hand side, so you'll get x squared equals 25. And then in order to get x, you need to square root 25. So the answer could be positive 5 or negative 5. Both can be accepted because when you substitute inside here x as 5, 5 squared is equal to 25. 25 plus 8, 33. So you see you get the same answer here. And then if your x is negative 5, if you replace x as negative 5 here, you put bracket negative 5 and then square it, you also get 25, right? Plus 8. The answer will be the same as here, 33. Okay? Okay, next example. Okay, find the value of x, the length of AP, and the length of OP. Okay? So, we will see the solution in the next slide. Okay. In order to get x, look at your x. Your x is located here. Okay. So we need to look at this triangle. Okay, as you can see, we need to find this angle before we can get x. Okay, because I can use 180 minus 90 and then minus this angle and then I will get my x. Correct or not? Okay, so angle BPO is actually half of the 60 degree, right? Okay, half of 60 degree. You see, this one is actually 60 degree. So I just want half of it. So I will use 60 degree divided by 2 and then I will get 30 degree. Okay, I will get 30 degree. Okay, so the 60 degree just now is already split into two 30 degree. Okay, next. Now, very easy for you to find x. Okay, as you can see here, this is a right angle triangle and the sum of the right angle triangle will be 180. Okay, so in order to get x, you use 180 minus 90 minus 30. So we will get 60 degree for your x. Okay, next. How are we going to find the length of AP? Okay, AP is actually equal to BP, right? But it's okay, I will use the right angle triangle up here to show you the solution so that you won't be so confused up and down like that. Okay, so we will just focus on the right angle triangle up there. Okay, so again, this is radius, this is tangent, so we will get 90 degree here. If the question didn't tell you about this, okay, so you should know because you already learned the property. Okay, but this question is very kind-hearted, so they give you already 90 degree. Okay, all right, so this is a right angle triangle. So I want to find AP. I have the length of radius and then I have 2 out of the 3 angles here, so I could actually use the trigonometric ratio. Okay, which you learned already before, right? Chapter 5, yeah. Okay, so now in order to use trigonometric ratios, you need to know the Chinese man so ka toa, right? So you need to know what is your hypotenuse, what is your opposite, and what is your adjacent. Okay, now we will look at this from this view, 30 degrees. So your eye is over here. Okay, so for this triangle, the blue colored line will be the hypotenuse because it is opposite to 90 degree. And then as you build from here, the opposite side will be AO, okay, or OA. Okay, so the side that is left behind here will be your adjacent side. Okay, so hypotenuse, opposite, adjacent. So now, which trigonometric ratio should be used? Sin, cos, or tangent? So I need to know what I want to find actually, right? I want to find AP. So it is regarding adjacent. So I need to use trigonometric ratio that is concerning about adjacent side. So, ka, tua. I need the A. So, of course, out already because SOH. There's no A there. So I need to use either ka or toa, right? So if I want to use ka, I need not only I need to find A, I need to get my hypotenuse, right? If I want to find my adjacent, I need to get the hypotenuse. I need to know what is my hypotenuse. But in this case, I don't know what is my hypotenuse. So it couldn't help me with the ka. So I need to go for the last choice. Toa, okay? Tangent, because tangent is equal to opposite over adjacent. See, I got the value for opposite. So very easy. So I will use tangent 30 degree equals to OA, which is 13 over AP. AP is what I want to find. Okay, so I just replace OA with 13. And then in order to get AP, you switch with tangent 30. AP going up and then tangent 30 degree going down. Okay, so the answer will be 13 square root 3 centimeter. Okay, depends on question. If question wants you to express in 2 decimal places and then you convert it into decimal. Okay, and then to find C, which is the length of OP. Okay, so still we use this triangle. So OP is actually the hypotenuse. So I will need to use ONH. So OH. So I will use sin 30 degree equals to opposite 13 over hypotenuse, which is OP. So by using the same method as the previous one, you just switch it and then you will get AP is equal to 26 cm. Okay, you see this topic, why very difficult? why most of the students they don't like, because it connected to many topics. It could be connected to Pythagoras theorem. It could be connected to trigonometric ratio. And then now you learn the properties 3 in one question. So you better master all the concepts that you have learned before, especially Pythagoras theorem and trigonometric ratio. Okay? Okay, regarding the question just now, actually for question C, if you don't want to use trigonometric ratio to solve it, you can actually use Pythagoras theorem, right? Because as for B, you already got your AP. So actually you got 2 sides already. So in order to get OP, which is the hypotenuse, we will use the Pythagoras theorem to find it. So to find OP, we will need to get the square root of the square of 13 plus square of the adjacent, which is 13 square root 3. Okay, so you will get 26. It's actually the same, the answer, but with different method. Okay, next example. Example 15. This question a bit complicated, but you need to have some skill of drawing some line by yourself. Okay, so find the value of the length of AB. Okay, this length, and then angle APQ, this angle. So you see AP is not connected, so you need to draw it yourself. BQP, okay, this one also you need to draw it, and then ABM, angle ABM. Where is my M? Okay, never mind. We'll look at the example letter, the solution there. I may label it there. Okay, so this is the diagram. I copied it here. So I draw a radius from center Q to the point of tangency B. So I will get a radius here, and then this is also 3, right? Because the radius here is 3. So this one also 3. Next, okay, from the point of tangency A here, okay, so I draw another line here, okay, which will then connect it to P, but I didn't extend it because I want you I want to lead you to connect with this one later. Okay, so actually this one is 90 degree because this is radius and this is the tangent. Okay, so 90 degree. Alright, so this one is what I want to say. Actually extend it, so you will get the red line here is actually parallel to this one, which is also 3. Okay. Alright, so this is 3. So what is the line that I drawn before? Okay, that I didn't extend it until the center here. Okay, so what is the length of this one? Okay, you look at this. This is actually radius, right? If you turn it like this one also radius. Okay, this one also radius. Okay, so this radius is equal to this radius. So 11, 11. Now here already 3. So what is the balance here? 11 minus 3. It will be 8. Okay, so when we add up, we will get 11. Okay, next. Okay, this is the line drawn from the center P to the center Q here. Okay, so this line PQ is actually 17 unit. It is already been given here, 17 unit. Okay, now next. If I copy and paste this straight line, okay, then I draw it up here and parallel to line PQ, okay, so what happened? This line is also 17, right? This line also 17. Okay, next. To find AB, okay, which is the first question, AB, okay, I will use Pythagoras theorem because I can see a right angled triangle here. So this blue side is actually opposite to the 90 degrees, so x17 is actually the hypotenuse. So to get AB, I will use square root of 17 squared minus x squared. So the answer will be 15 cm. So AB is equal to 15 cm. Okay, next. Okay. What is the question B, question B is actually wanting us to find angle APQ, right? So angle APQ is actually equals to angle AMB. You know why? Because these two angles are actually corresponding angle. You learn this in form, I think form 1, okay? Corresponding angle. Okay, so I hope you still remember. If you cannot remember, you need to do revision. Okay, so in order to find angle APQ, I will use this triangle to help me to find, because I can use trigonometric ratio. Okay, so I will use cos of angle AMB. Why cos? Because I have adjacent side and also hypotenuse. Okay, I'm not going to tell you which one is adjacent, which one is opposite. You should know this angle. If you build it from here, this will be your opposite. This will be hypotenuse, and this one, the side that is left behind will be your adjacent. So you have A and you have H. A and H. So obviously we need to use CAH. So cos angle AMB is equal to adjacent 8 over hypotenuse. So in order to get angle AMB, you need to move your cos to the other side. So it will become inverse of cos. And then by using calculator, you'll get 61.93 degree. Okay, this is B. How about angle BQP? Okay. Okay, angle BQP is actually equals to 180 degree minus 61.93 degree. You know why? Because this is actually parallel as well. Okay, this one also parallel because they are radius, and then they are having the tangent here. So this is actually parallel. So when these two radius are parallel to each other, actually these two angle, which is angle MPQ and angle BQP, are actually interior angle. So interior angle, when we sum up, we will get 180. So to get this angle, you need to use 180 minus this angle. This angle, you already got it just now from here, right? Actually the same, which is 61.93. So you minus it, and then you will get the answer. Okay, 118.07 degree. Okay, as for question D, which is angle ABN, okay, here is my M. Okay, so to get angle ABM, very simple. You use triangle, right? You got two angles already out of 3. You got the two angles here, 90 and also 61.93. So to get this angle, you use 180 minus 90 minus 61.93. So you'll get 28.07 degree. Clear? I hope you understand, huh? Okay? Okay, we stop here.